Alright, what we're starting to get into now is when we have two equations or two expressions that are equal to each other. So what we're going to see is we're going to see variables on both sides. This is handy for letting us compare two separate things or two separate situations and say, well, when are they going to be equal? When is one going to be less than the other? When is one going to be greater than the other? So what we have here is a problem. We have a pine tree that's 4 feet tall when planted, and it grows at a rate of 2.5 feet every year. And then we have an oak tree that's planted at the same time, and it's 6 feet tall, and it grows at a rate of 2 feet every year. So what do we have to know first? First, we have to write out, well, what expression represents what we have? So I'm going to say, well, I have my pine tree. I know it's 4 feet tall when it's planted, so that's not being multiplied or anything. That's our constant. That starts out what we're at. Then I'm increasing at a rate of 2.5 feet per year. So that's going to give me 2.5x. So there's my pine tree expression. Now what I want to look at is, well, what's the expression for my other tree? Let's look at my oak tree. So my oak tree here, well, that starts out at 6.5 feet tall. So there's my constant. It's starting out at that much. And this one's growing at a rate of 2 feet per year. So not 2.5. Okay, so now we have our two equations right here, our two expressions. Now we're ready to start looking at it. So let's look at the question right here. An equation that can be used to determine the number of years that will have to pass in order for the trees to be the same height. So if I want them to be the same height, that means I want my pine tree's height to equal my oak tree's height, because both of these expressions right here are going to give me the tree height. Okay, so I want pine tree to equal oak tree. So what I'm going to do is I'm just going to say, all right, well, let me substitute my expressions in. So instead of my pine tree, I'm going to put 4 plus 2.5x. I want them to be the same, just like I have an equal sign over here. I want to have an equal sign over here. And then now I put my oak tree on the other side. 4 plus 2x. And there is our equation. Right? We have variables on both sides, but this is going to tell me when my heights are the same. Okay? So, let's look if it's not an equal sign. Right? So let's look in this case right here. Now I want an inequality. Okay? I'm still looking at my same problem, right? I still have my pine tree. He's 4 feet tall with a rate of 2.5 per year. And then I have my oak tree, which starts at 6.5 plus 2 feet per year. So there's my starting. So I want the inequality that can be used to determine the number of years that will have to pass for the pine tree to be at least as tall as the oak tree. So if I want it to be at least as tall, that means I want it to either be greater than or equal to. This at least as tells me greater than or equal to. So I want my pine tree greater than or equal to my oak tree. So let's rewrite it again, filling in our expressions. 4 plus 2.5x, that's my pine tree. I want it to be greater than or equal to my oak tree, which is 6.5 plus 2x. And there's our inequality right there. So all we're doing is we're saying, all right, this is what I'm looking for. These are the expressions that represent each scenario. Now, do I want them to be equal? Do I want them to be less than or equal to, greater than or equal to, so on and so on. So that's what's going to figure out what goes in there. So that's the basics of getting those equations or expressions out of the scenario and how we're going to set them equal or set up an inequality between the two.